Okay, for our last part of our final challenge, in Excel, we are now looking at the male data. So we are going to come over here and look at the number of words spoken by people who identify as males in one day. So these range all the way from 1,569 up to 36,345. We found a lot of these summary statistics earlier, but now we're actually working with these for a confidence interval. So our point estimate here, this is find the best point estimate for the proportion of males who speak less than 16,000 words a day. So if you remember up here, we actually had this little Scratchwork section that you can use if you would like to for this problem. So here we're looking for N1, they're calling that is the number of males total. So if we come over here, we can highlight all of these or use the count function to see how many there are. In this case, there are 30. We can see this down here. Again, you can use that count function as well. So out of 30 people who are male in this survey, we have a certain number of them that speak less than 16,000 words per day. So let's go ahead and find where that cutoff is. This is the last value because these are sorted. So if we highlight all of these, we can see down here 19. So there are 19 people who identify as male in the survey out of the 30 who speak less than 60,000 words per day. Okay, so let's scroll back down. Now our point estimate, again, we're working with proportions, so this will be p hat again. Our point estimates will always be sample statistics, so sample mean, sample proportion, etc. We're estimating the population proportion based on the sample proportion. All right, so here we have a sample proportion. We're looking for the proportion of males who speak less than that many words per day. So we can type equals, come up here to grab the number of males who speak less than that. And we will divide that. So I'm going to type divide. You can see it right here, even though we're not down in the cell where you can see it. So L50, which is this cell, divided by this cell. So 19 divided by 30. Let's scroll back down so we can see that. That would be our x divided by n for our proportion. And we get 0.63. So let's scroll down and check that. Awesome. 86, we're almost there. All right, so that's our point estimate. And remember, when we build a confidence interval, we have our point estimate, and then we add and subtract our margin of error. And then that's when we get our lower bound and our upper bound. That's a B. I don't know why. Upper bound. Okay. So we have our point estimate. And now we need to calculate our margin of error. To do that, we first need to calculate our critical value, which is the number of standard deviations or the number of standard errors we want to go above and below our point estimate. So here we're working with a 98% confidence interval. What that means is for our distribution, we're putting 98% in between whatever two bounds we find. And that means in the edges, there is 2% left for the tails, which really means 1% in each tail because we divide that by 2. So when we use this function here, we're using norm.s.inverse. Again, that returns a z-score. We need to put in the probability to the left of the value we're finding. And before I even do this, I want to point out why we do the 1 minus. So what we're doing here is we're actually finding the z-score that corresponds to this value because this is the positive z-score. If we were to find this one, it would end up being a negative critical value, and we want the positive one. So that's why here we subtract that probability from 1. So we can do norm.s.inverse 1 minus 0.02 divided by 2. Again, the 0.02 is coming from like the leftovers from the 98%. So 1 minus 0.98 is that 0.02. Okay, and even notice there, now we can start seeing this moving in real time. That is correct. Our margin of error, recall, is z alpha over 2 times our standard error. So we need to go calculate our standard error. let's scroll up here. We can find at least close to what our standard error is here. Okay, and again, these are our test statistics, but our standard error is represented with our p-hat. So even though this looks very, very similar to what we're calculating, we're not using p because we don't have a value for p when we're doing a confidence interval. We have an assumption for p when we're doing hypothesis testing for proportions, but we don't have an assumption for that when we're doing confidence intervals. So we use p-hat and 1 minus p-hat for our standard error. So, in fact, I'll write that. Our standard error is the square root of p-hat times 1 minus p-hat all over n. So let's do some scratch work over here. So my standard error then is equal to the square root of p-hat. So I'm going to come click on p-hat. Again, that I need that exact value. I can't use the rounded 0.63. I need to click on that. So the square root of p-hat times 1 minus p-hat. So now we have p-hat times 1 minus p-hat all over n. Now remember, this n, we're no longer looking at the female sample. We're looking at the sample with males. So our n is 30 in this case. Just remember what population and what sample we're working with. Okay, so if you see here, we have the square root of, and all of this is inside the square root. The square root of p-hat times 1 minus p-hat divided by n, which was 30 in this case. Okay, so that's our standard error. So now when we come up and calculate our margin of error, we can type equals, use this z alpha over 2. Again, when we're using z-scores and z-score tables and t-score tables, those are all rounded. Excel finds exact values for those. Okay, so this times, that's our critical value, times the size of a standard error. Again, we're counting how many standard deviations are we adding and subtracting from the point estimate to build this confidence interval. Okay, when we do that, our score should go up, and it did. So our margin of error here, rounded, is 0.20, but I will show you it's a very exact number. Okay, finally, for our confidence interval, when we build this, what we need to do is our parameter is the population parameter. So we're estimating the population proportion based on our point estimate, which is the sample proportion. Okay. Our lower bound, we take our point estimate, which is this value. I don't even want to say 0.63 because that's rounded, but our point estimate minus our margin of error. And again, you need to be clicking on these because they are specific exact values. So our point estimate minus our margin of error, yay! And our point estimate plus our margin of error. And when we do this, hopefully it's 100. Ta-da! So again, what we have done now is we have built this confidence interval. So we're claiming that this is 0.43, this is 0.84. So we're saying we are 98% confident that the true proportion of males, or people who identify as male, who speak less than 16,000 words in a day, we are 98% confident that that value falls between 0.43 and 0.84. So about 43 and 84%. Okay, and we're done. We have 100 on our final challenge. So please take your time as you are working through these. Remember that you can slow me down using that gear icon in the bottom right, back up, redo things. Please email me if you have questions. And just let me know how it's going. I will be available for my student hours on Wednesday from 3 to 4, so please jump in there. But again, I will email pretty quickly if you email me either through Canvas or on my school email. So good luck, and yeah, let me know how it's going. Bye.